Hello everyone, my name is Vitaly. Today we are testing this high voltage DC-DC converter from AliExpress, which costs about 15 euro. It takes 12 volts at the input and outputs 400 volts. If you are wondering why I need 400 volts, check out the link to the full article in the video description. Just to mention, 400 volts is extremely dangerous. This cheap converter is fully capable of killing you. If you don't have the proper knowledge and experience with high voltage, don't try to replicate what you see in this video. The manufacturer claims that the converter provides 500 watts of power. Let's check if that's true. For those who are interested, here are the names of the controller IC, Mosfet transistors and transformer. The converter outputs AC voltage at 20 kHz. To convert it to DC, I sold the diode bridge and smoothing capacitor. I also have this vintage voltmeter, and in the background you can see a huge 500 watts resistor that I'll be using as a load. For additional safety, I insulate the exposed diode leads with heat shrink tubing, though even without it I wouldn't be poking around a live circuit with bare hands. The PCB has no input terminals, so I have to solder wires directly to it. To connect it to a car battery, I bought these clamps. And to measure power consumption, I'm using a voltmeter and ammeter, which can work with very high currents. First, power on, no load. Oh! The Mosfet exploded. What a great start to the test. The DC-DC converter burnt out within the first second of powering it up. After desoldering the damaged Mosfet transistor, I turned the circuit on again. This time smoke started coming from a resistor. Later I found out that it was the gate resistor for one of the Mosfets. What went wrong? I have two possible explanations. First assumption, the controller AC didn't start up fast enough and applied a low gate voltage, leaving the Mosfets partially open, causing them to overheat and explode. Second assumption, which I came up with after recording this video, the transformer, when running without a load, might be generating high self-induction voltage when Mosfet switched off. This voltage could exceed 55 volts, which is breakdown voltage of the ERF3205 Mosfets, leading to the failure. To verify this, I'll need an oscilloscope, and I'll definitely show you the waveforms in one of the next videos. Fixing the circuit. For now, I'm removing the burnt Mosfets and replacing the damaged gate resistors. Luckily, the resistor values were printed on the board. They are 10 ohms. When the Mosfets burnt out again, I decided to connect them with wires to make future replacements easier. Also, I added a push button with wires connected to the shutdown pin of the IC. Now I can safely connect the circuit to the battery, and the controller will only start switching when I press the button. For output power measurement, I connected two multimeters, one in voltage mode and the other in current mode. Success! It works! Multiplying the voltage by current, we get the output power. The DC-DC converter consumes 361 watts at the input. The output voltage is 323 volts and the power is 314 watts. That gives us an efficiency of 87%. Not bad at all. So this converter delivers about 300 watts, far from the claimed 500 watts. And even then, there is a significant voltage drop and load. But this is only the beginning of the experiments. Output power and efficiency depend on switching frequency, gate resistor value and input voltage. In the next video I'll be adjusting these parameters to see how they affect power output and efficiency. I'm sure I can extract a bit more power from this converter, or maybe a lot more power. If you enjoyed this experiment, hit like and don't forget to subscribe. More exciting experiments coming soon.